I'm not a scientist, but I have a feeling that when atoms are energized, that is how they behave under the microscope.
Hello, welcome to Solution Prime TV, and today we are going to talk about polygons. We are going to define polygons and solve questions under polygons. In the first place, what is polygons? So I have the definition here. A polygon is a shaped closed figure with a straight size. So any shape which is closed with a straight size, then it is a polygon. For example, if I pick triangle is a polygon because it has straight size and it is closed. If I pick something like this is not a shape which is closed. And if I have something like this is not polygon. Why? Because we have one straight, another straight line, but this line is not straight, so it is not a polygon. So we have types of polygons. We have regular polygons and irregular polygons. For regular polygon, a regular polygon is a polygon that has equal interior angles and equal size. So when you have any plane figure or shape with equal angle and equal size, then it is regular polygon. For example, we have equilateral triangle. We all know equilateral triangle. We did properties of equilateral triangle, angles in a triangle. We've done that in the previous video, which is angles, its real life applications and calculations. That is a full video. Anything about angle is there, so you can see the properties of equilateral triangle, properties of isosceles, scaling. They are all there, so you can go and check it out and watch so that you get more insights. Okay, so let me pick equilateral triangle. For equilateral triangle, for every equilateral triangle, all sizes are equal. That is the properties of equilateral triangle. So in equilateral triangle, you see something like this, telling you that all the sizes are equal and all the angles are equal. Automatically, if all the sizes are equal, the angles will be equal. Yes, so that is that. Okay, we also have square. For square too, square has all sizes being equal. Then we also have their angles being equal. So over here the angle is 90, here to 90, 90, and also 90. The sizes are equal and the angles are also equal. For equilateral triangle too, we have 60 degrees, 60 degrees, 60 degrees. So that is the properties of equilateral triangle and square. Okay, so we also have regular examples. If you talk about equilateral triangle, square, we have regular, quadrilateral, regular pentagon, regular hexagon, They are all examples of regular polygons, because a pentagon can be a regular or irregular. Okay, so that is it. So I will show the examples of regular polygon and irregular polygon on the screen for you to know. Okay, for irregular polygon is a polygon that has no equal size and equal angles. Example is scaling triangle. we have rectangle, we have trapezium. So that is that. So if I pick scaling triangle, all sizes are not equal. All sizes are not equal. So you see something like this, it's telling you that this is not equal to that and it's not equal to that, and their angles are not equal. Their angles are not equal. So it falls under irregular polygon. We also have rectangle. You know that rectangle, the angle inside, one of the properties of rectangle, the angles inside are 90 degrees, 90 degrees, 90 degrees, 90 degrees. Yes, correct. But you see, the sizes are not equal. This size is equal to that. This size is equal to that. But they are all not equal. If they are all equal, then it will fall under regular polygon. Trapezium has a shape like this with height. Yes, so all the sizes are not equal and the angles are not equal. So that is that. And rectangle, trapezium falls under irregular quadrilateral. Yes. So when talk about quadrilateral, it's a shape with 4 sizes. So 1, 2, 3, 4. 1, 2, 3, 4. So they all fall under irregular quadrilateral. Over here we have regular quadrilateral. Over the regular quadrilateral will be our square, because the sizes are equal, because it is regular. The sizes are equal and the angles are equal. But over here they are not. Okay, so examples: irregular quadrilateral, rectangle is part, trapezium, rhombus is also part, parallelogram is also part. Yes. Kite is also part. So these are all examples of irregular quadrilateral. Another example: irregular pentagon, irregular hexagon. They are all examples of irregular polygons. Okay, so these are special types of polygons and we are going to solve them. It can be regular or irregular, but most of the questions will be based on regular polygons. So the first polygon is triangle. It has 3 sides. Yes, because if I have 2 sides, 2 sides can never form a shape or closed shape. There's no way you can get a closed shape or plane shape. Let's closed shape. Yes, there's no way. So the first polygon is triangle, because when I add another line, I'm going to get a closed shape. The second one is quadrilateral, 4 sides, pentagon, 5 sides, hexagon, 6 sides, heptagon, 8, octagon, 10, nonagon, 9, decagon, 10, decagon, I think I've made a mistake here. So nonagon is 9 and decagon is 10. Hey, let me see. Okay, yes, heptagon is 7. Octagon is 8. Nonagon is 9. Decagon is 10. Undecagon is 11. Duodecagon is 12. Triskaidekagon 13. Then tetrakidecagon 14. Pentadecagon 15, and so on and so forth. Yes, so if it is 20, it has its specific name. So that is that. Okay, we are done. We are going to move to the calculation aspect of polygon. we are going to talk about internal, the general formula of interior angle of a regular polygon, and the general formula of exterior angle of a regular polygon, then sum of interior angle of a regular polygon, and sum of exterior angle of a regular polygon. Yes, these are the calculations you are going to do. And I told you that we are going to do more calculation on the regular polygon because their sizes are equal, their angles are equal. So we can find, if you're able to find one angle, then that angle goes for the other angles. That is it. So it helps us to calculate for the size and the angles. But we will solve questions to under irregular polygon, but it's not going to be more than that of the regular polygon. Will be more, yes, because they are flexible and they are easy to do calculation on that. Okay, so before I will move on, let me explain interior angle and exterior angle of a regular polygon. So interior and exterior. So interior and exterior angle of a regular polygon. So assuming I have okay, so this that are the interior, their interior inside angles are called interior, and outside angles are called the exterior. They are outside, they are outside, they are outside. So that is it, interior angle and exterior angle. But before we start, I'm going to write all the formulas that falls under polygons, the general formula and the sum formulas, so that you know they are four, only four. If you know the four formulas, then you are done. Anything about polygons, you'll be able to, solve that. Sorry. Okay. Okay, so these are the formulas and the polygon, and I said earlier that because external what do you call irregular polygon is difficult to handle, your level, if you are in JHS, if you are in ACHS, you are going to do your calculation under regular polygon. So these are the regular poly. These are the four regular these are the four formulas under a polygons as a JHS student or ACHS student. And for interior angles, if you want to find one interior angle of a regular polygon, then it is n minus 2 times 180 degrees over n. If you want to find for the sum of the interior angle, for example, if I have something like this, and this one, let me draw it again. For example, square. Since it's regular polygon, their angles are the same. So if here is x, here will be x, here will be x, here will be also x. So if you want to find the interior angle of a regular polygon, then you quote from this formula. We know that for square it has 90 degrees. Each angle is 90, so 90, 90, 90. But we are using the formula to prove that. So we are going to use interior angle is equal to n minus 2 times 180 180 degrees divided by n. Okay, so we know that square has four sides: 1, 2, 3, 4. So that is the n here is the number of sizes. The n number of sides, that is n. So I have my 4 minus 2 times 180 degrees divided by 4. So n minus 2 will give me 2. 2 times 180 degrees divided by 4. Don't multiply because we are going to get huge value. 2 goes inside 1, goes here 2, and we have 180 degrees divided by 2. 180 degrees divided by 2 is equal to 90 degrees. So we prove that so this one, we prove that the angles in a what do you call it, square is 90 degrees because it is what, regular. If it is not regular, there's no way you can use this formula and you get the answer, because if you're able to get 190, one side to be 90, other sides to other angles to be different. Okay, and because the sizes are not equal, you can never solve it because the number of sides is included and the angles is also included, making a complete formula for finding the interior angle of a regular polygon. So if I want to find for the sum too, we can also prove that we already know the properties of square. Their angles 90, 90, 90. So 90 plus 90 plus 90 plus 90. So 90 plus 90, 180 degrees. This one to plus 180 degrees. And 180 plus 180, you are going to get 360 degrees. That is that. Let's use the formula to prove that. Exterior n minus 2 times 180 degrees. So how many sides do square has? 4. 4 minus 2 times 180 degrees. So you subtract, you're going to get 2 times 180 degrees, which is equal to 360 degrees. Yes. And the rule is that every quadrilateral, the sum of interior angle of every quadrilateral is 360. So square will get 360, rectangle will get 360. So that is how we solve those questions. Cool. Let's move on to the questions. Basically, the interior angle of a regular polygon, this one is for regular polygon. You can only use for regular polygon. Yes, exterior angle of a regular polygon, you can use this one. But for any polygon, whether regular or irregular, the sum is the same thing. The sum of interior angle is the same thing. The sum of exterior angle is also the same thing. But for the first one, there's no way it's going to be the same thing. Yes, because based on the understanding of what you've learned, this one, when you find n, that is the angle, that particular polygon. Yes, so that is that. But for the sizes, if the sizes are not equal, you count the number of sizes minus 2 times 180, you are going to get the same answer. But this one, we are finding one angle, and that angle is supposed to be equal to the other angles in that polygon. Yes, so this one, you can see sum of interior angle of irregular polygon, we are going to get the same thing here. So yes, that is that. So we are going to solve questions under it. We are going to solve questions under it. Listen, let me give you a clue. You see, if you know the interior angle of a regular polygon and the exterior angle of a regular polygon, you are done. You don't have to waste your time. We have interior angle n minus 2 times 180 degrees. The sum, you just clear the n. The second one to 360 degrees over n. The sum, you just clear or eliminate the n. You eliminate the n, you will get the sum. So that's the easier way you can remember. So if you know these formulas, you are done. Any questions under polygons, you will be able to answer. Okay, so let's try questions. Okay, so these are the questions. You are going to try our hands on it. Okay, so you can feel free and pause the video and try your hands on it before we will start. Okay, so solution. First one, find the sum of interior angles of a regular polygon with C size. So you know the formula for finding interior angle of a regular polygon. That is it. Of it. So the sum of exterior is equal to, sorry, interior, sum of interior is equal to, sum of interior is equal to n minus 2 times 180 degrees, where we know that n is the number of size. So we're given the number of size to be 6. So 6 minus 2 times 180 degrees. 6 minus 2, which is 4, times 180 degrees. 4 times 180, you will get 720 degrees. Yes, 720 degrees. You can punch it on the calculator. As a SHS student or JHS student, you need to do your calculation. 180 times 4. You do your calculation on that to get 720 degrees. Okay, let's move on to, so a regular polygon with C size is called hexagon. That is it. Okay, let's go to the second question. Okay, let me hold on so that we can use the formula over there. The second one, a polygon has 10 sides, so you know that n is equal to 10. Find the sum of its interior angle. So we are finding the sum of its interior angle. But before we find the sum of its interior angle, it's easy, right? So sum of interior angle. Let me introduce angle here. Angle. Yeah, so sum of interior angle is equal to n minus 2 times 180 degrees. So we have 10. Yeah, 10 minus 2 times 180 degrees. So 8 times 180 degrees be 1440 degrees. So we have 1440 degrees. So that's the final answer. Let's try the question number 3. If the sum of the interior angles of a regular polygon is 540 degrees, find the number of sides. So right now we're given the sum of the interior angle and they are telling us to find for the side. Okay, so you quote the formula, sum of interior angle. We know the formula, n minus what, 2 times 180 degrees. Okay, but this is the sum of interior angle. That is the formula. And in the question, they are saying the sum was 450 degrees. So you indicate your 450 degrees. If 540 degrees, you indicate your 540 degrees equals n minus 2 times 180 degrees. We are going to find for n because in the question we are asked to find n. So mathematics, we are going to have 540 is equal to this 180 will multiply n, which is equal to 180n minus negative 2 times 180, which is negative 360. Yeah, 360. You do cross multiplication, it depends on you. You can bring the n here. When it crosses the equal to sign, it's going to be negative n. Then you send this one there. It's up to you. Or you can maintain this and you have your 540 degrees plus this one will cause the equal to sign to come plus 360 degrees equals 180 n. So it's not compulsory that always the n is supposed to be here. No. Yes, if you like, you can choose it, or you can send your n here, or negative 180 to be your negative 180 here. Okay, so this one we are going to have 900 900 degree. You let me indicate the degree once I've started with the degree, equals 180 degree n. Okay, so you divide both side by 180 degrees. 180 degrees. The reason why we are dividing both sides by 180 degrees is that we want n, number of sides. So 180 degrees is attached to n. So we have to divide by 180. And since this is equal to that, if you are dividing by this, it will automatically affect this because they are equal. If they are equal, if you multiply by this, you have to multiply by this. If you divide by this, you have to divide by this. That is the law or the rules of mathematics. Okay, so this one will cancel this. We are going to have n is equal to 900 divided by 180, which is 5. Okay, so we can conclude that therefore n number of sides, therefore the question, the number of sides is 5. Okay, so that is that. Easy questions. Cool. We are going to solve another set of questions, because when you solve more questions, it opens your mind. You see, these questions basically is under sum. Okay, so let's solve another question. Okay, cool questions. Okay, let's solve this question. Okay, so the first one, find the interior angle of a regular polygon with C sides. So interior angle, we know that interior angle of a regular polygon, interior angle of interior angle. So interior angle, without writing it full, interior angle of a regular polygon, you can write interior angle is equal to, we know the formula, n minus 2 times 180 degrees. Okay, so the number of sizes is 6. So I have my 6, sorry, divided by n. Yeah, divided by n. That is it. If there's no n, then it is sum. It is, if there's no n, then it is sum. Okay, so we have 6 minus 2. So we have 6 minus 2 times 180 degrees divided by 6. So that is that. Let's continue from here. So we are going to have 6 minus 2, which is 4. 4 times 180 degrees divided by 6. And we know that 2 goes here, 2 goes here, 3. Yes. So 2 times 180, which is 360. It's not coming. 360. So 360 over 3, which is 120 degrees. Yes, 120 degrees. That is cool. The second one, the interior angle of a regular polygon is 120 degrees. How many sizes does it have? So we are calculating for the sizes and we're giving the angle to be 120. Listen, the interior angle of a regular polygon. So interior angle, we know that interior angle is equal to the formula n minus 2 times 180 degrees divided by n. That is the formula. So we're giving the interior angle of a regular polygon to be 120. So over here, our angle here is going to be 120 degrees. 120 is equal to, we have n minus 2 times 180 degrees divided by n. So we are finding for n. This one, you can find LCM. The LCM is 1 and multiply by each term. Or you can do cross multiplication. This is over 1. So 1 will multiply the whole of this, and this will multiply this. So n times 120 degrees, you are going to get 120 degrees n is equal to n minus 2 times 180 degrees. So 120 degrees n is equal to 180 times n, 180 degrees times n. You're going to have 180 degrees n minus 360 degrees. So this one, you can choose to, allow cross this one, or you can still maintain this, send this one there and bring this one 360 here. So let me send this one, 120 degrees n minus 180 degrees n is equal to 360 degrees. So that is that. If I subtract 120 degrees, if I subtract 180 degrees n from 120, I'm going to have negative 60 degree n, which is equal to 360 degrees. Oh, sorry. Over here we have our negative. Yes. We divide both sides by negative 60 degree n, both sides by 60 degree n. That is it. So negative 60 degrees will cancel negative 60 degrees, and you are going to have n is equal to 0 cancel 0, negative 36 divided by, so again negative will cancel negative, and 36 divided by 6 is equal to 6, which is 36. So we have the number of sides to be 6. Easy. Okay, let's try the last one, which is the 3. This one is okay because the duster is dirty, it's making the board dirty, so let me use this. Okay, so the question number 3, a regular polygon has 10 sides. A, the exterior angle, find its exterior angle. A, find its exterior angle. So A, exterior angle, you know that exterior angle of a regular polygon is equal to 360 degrees over n. Okay, so 360 degrees over 10, which is equal to 36. Yes, 36 degrees. So that is the angle. We're asked to find the angle. Second one, which is the B, the sum of interior angle. So sum of interior angle, we know that it is equal to n minus 2 times 180. So the thing is formula work. If you know the formula, you are free to go, which is equal to, we have 10 minus 2 times 180 degrees. So we have 8 times 180 degrees. So 8 times 180, which is 1440 degrees. So we are there. This is a cool question, very cool question. So let's try another set of questions. You see, the more you solve questions, the more you get the understanding. So we are going to solve another set of questions. Okay, cool questions. You can feel free and pause. And try hands on. Okay, let's move on. Okay, the first question, the interior angle of a regular polygon is twice its exterior angle. Okay, find the number of sides, the interior angle. So you go to your interior angle. Interior angle of a regular polygon is twice, then it means it is equal to, twice means 2 times its exterior angle, that is exterior angle of a regular polygon. So the interior angle of a regular polygon is twice its exterior angle. That is it. Mathematically, that is the interior angle is equal to 2 times its exterior angle. They can also change the question. You can write it in this form. The exterior angle of a regular polygon is twice its interior angle, or the interior angle of a regular polygon is thrice, which is 3 times its exterior angle. So how do we frame the question? If you understand, you understand. So interior angle, what's the formula for finding interior angle of a regular polygon? The formula for finding interior angle is n minus 2 times 180 degrees divided by n is equal to 2 times the formula for exterior angle. We know the exterior angle of a regular polygon is 360 degrees over n. That is that. So we know that you are going to have n minus 2 times 180 degrees is equal to 2 times 360, which is 720 divided by n degree. This is over n. We will do cross multiplication. You can use that. You can do cross multiplication, or you can find the LCM multiplied by each term, and the LCM for n and n is n. So I'm going to have n times the whole of this, n minus 2 times 180 degrees, all divided by n, which is equal to n times 720 degrees is equal to n. Yes, because the LCM is n, so you have to multiply each term by the LCM. That is math, how we solve math when we have question like this with LCM. Okay, so this will cancel that, and this will also cancel that. See, if you like, you can move to this method. Since the LCM are the same thing, the top one is equal to the top one. That is that. So if I cancel this, I'm going to have this is equal to the top one. It's the same thing here, and it's the same thing here. This is multiplication. Yes. So you are going to have n minus 2 times 180 degrees is equal to 720 degrees. You multiply through 180 and minus 360 degrees, which is equal to 720 degrees. Okay, so we are going to have 180 and is equal to 720 plus 360 degrees. So 180 and is equal to 720 plus 360, which is equal to 1080, yes, degrees. It goes about 180 and degrees, 180 so yes, 180 degrees. So 180 degrees will cancel 180 degrees. Sorry, there's no n here because we are finding for n. So we're going to have n is equal to 1080 divided by 180. We are going to have 6. So therefore the number of sides of the polygon is 6. Okay, so that is that. Let's solve the question number 2. Question number 2. The exterior angle of a regular polygon is 40 degrees. Find the sum of its interior angle. Okay, so we know that exterior angle of a regular polygon is 360 degree over n, and they are saying it's 40. Okay, so find the sum of its interior angle. So this means that we have to calculate for the n, then we use the n to find its sum. Wow. Okay, so here we have 40 degrees is equal to 360 degrees over n. Okay, so this one you can do cross multiplication. This is over 1, this is over n, so cross multiplication. So we have 40 degrees, n is equal to 360 degrees. Okay, so you divide both side by 40, both side by 40. So we have 40 will cancel 40 degrees, so we have n, 0 goes here, and 36 divided by 4, we are going to have 9. So therefore the size is 9 size. Okay, then find the sum of interior angle. Okay, so the sum of interior angle is equal to n minus 2 times 180 degrees, and n minus 2, we have the size is 9, so I'll substitute in n minus 2 times 180 degrees. So 9 minus 2 will give you 7 times 180 degrees. You punch it on the calculator or you do your own calculations and you are there. So which is 1260 degrees. You try and see whether you get okay, that is great. So we are going to move on to exterior angles. You've done you see, we are moving on to the diagram. They will give you a diagram and they will ask you to solve it. So that is our last question, and we are done. Find the value of x in each of the figures. I think it's not clear. Let me use. So A, then B, Okay, so we have these two questions and we are going to tackle with these questions and uh, we are done. Okay, so and we are going to apply the same concept, the formulas, we are going to apply them. Find the value of x in each of the following figures. So we have this diagram, and this diagram, the angles are inside. The angles are inside. So you have to calculate for the sum of interior angle first, because when you add up all these things, it should be equal to some specific value. And we know that if you add the interior angle of a regular polygon, it must be equal to some value, and we are going to use the formula. Okay, so you have 20 here. Okay, so first of all, you have to calculate for the sum of each interior angle. So you calculate for the sum of each interior angles. So we know the formula for finding sum of interior angle of a regular polygon. So interior angle is equal to n minus 2 times 180 degrees. Yes. So how many sizes do we have? 1, 2, 3, 4, 5. 5 sizes. So we have 5 minus 2 times 180 degrees, and is equal to 3 times 180 degrees. So 3 times 180 degrees is 540 degrees. 540 degrees. Yes. 1, 2, 3, 4, 5. Yes, you've gotten. But you see, if you know the interior angle of this polygon, which is 5 pentagon, yes, 5 pentagon, if you know it off head, you can quote straight for interior angle of a pentagon is 550 without going through this process. It's the same answer. It's the same thing. You have the same marks with someone who did that. Okay, so we calculate for the sum of interior angle. Okay, so let me write it for sum of interior angle. So indicate that. Okay, so we have 2x plus x plus 3x plus 2x plus 30 degrees plus x plus 20 degrees is equal to 540 degrees. Okay, so 2x plus x, which is 3x plus another 3x, 6x plus 2x, 8x plus x, which is 9x plus 30 degrees plus 20 degrees, which is 50 degrees, which is equal to 540 degrees. Okay, so grouping of like 9x is equal to 540 degrees. This one will cause the equal to sign. You can minus 50 degrees. You subtract nx is equal to 490 degrees. You divide both sides by 9, and our x 54.4 degrees. Yes, try that. Okay, let's move to the b. For the b, it depends on you. You see, the angles are outside, so you need to it's external, exterior angle. Yes, they are outside. If they are outside, then we know the general formula. Sum of exterior angle is equal to 360 degrees. So every exterior angle of a regular polygon is equal to 360. We don't care the number of sizes it has. Yes, so once it is external, perfect, it is 360. When you add them, you have to get 360. So we have x here plus 50 plus 2x plus x plus 30 plus 3x is equal to 360 degrees. So that is that. X plus 2x plus x plus 3x. So x plus 2x, which is 3x plus x, 4x plus 3x, 7x. So we have 7x plus 50 degrees plus 30 degrees, which is 80 degrees, is equal to 360 degrees. So we have 7x is equal to 360 degrees minus 80 degrees. So 7x is equal to 360 degrees minus 80 degrees is 280 degrees. You divide both sides by 7. Both sides by 7. Okay. Then we have our x to be equal to 40 degrees. So that is it. We are going to have 40 degrees. We divide both sides by 7. 7. Yes, 40 degrees. So these are the questions under polygons. We are done. Make sure you keep on watching and subscribe to this channel and follow for more. Yes, they can also give you question like this, which will have 2x and will have an external ones 3x. Okay, you see, or something like this. So it depends. If you want to use external one, you solve it external. You use the formula, this formula, and you add all the external and you equate it to 360. That is the exterior angles, and you equate it to 360. Or you can use the sum of interior angle. You will calculate for it, and you add all the interior angle and you equate to the sum of the interior angle you calculated. So something like this too. Whether you can apply interior or exterior. So the easy one is to apply the exterior, because exterior, you know that it is always 360. You don't have to waste your time calculating for this. So that is that. Thank you very much.